Hi, this is Engineer Ahmed again. In this lecture, we are discussing electro-pneumatic converter, electro-pneumatic transducer or converter. So we'll take example of Fisher model 546. It is also called I bar P. I means current, P means pneumatic signal. So current to pneumatic, or you can call it electro-pneumatic. So basically it is a transducer, but we will also call sometimes electro-pneumatic converter. So it is a very important part of the pneumatic control valve. As we have seen earlier, in the pneumatic loop, the controller gives the standard current signal 4 to 20 milliamperes current signal to the transducer, which will be converted into 3 to 15 psi pneumatic signal, that is the air pressure. 4 to 20 milliamps to 3 to 15 psi precisely it has to convert. So that will operate the control valve through positioner. That positioner we will discuss in the next lecture. So in this we will discuss the electro-pneumatic converter. So it is completely sealed unit. It is mounted on the pneumatic actuator. There is a pneumatic connection here. Pneumatic supply is required, that is connected here. And the other side you will have a signal coming, pneumatic signal coming out, going to the positioner of the pneumatic actuator. So this is a sealed unit for whose cover is removed, and there is a terminations here. So here there is a terminations. Two wires are coming from the controller. Controller may be from the DCS or from a PLC or a dedicated controller, which is giving a 4 to 20 milliampere signal based on the controller action. So that is connected here. So if you see the scheme, so it looks like this. So these are the plus minus two terminals which is receiving 4 to 20 milliamps current signal from the controller. So we will study the construction of this electro-pneumatic converter. So here the heart of this mechanism is iron beam. This is the iron beam. This is a beam, iron beam, between the poles of a permanent magnet assembly. Between the poles of this permanent magnet, north, south, this is the assembly. Permanent magnet assembly. This is the north pole, this is a south pole. This is a permanent magnet and centered within an electromagnet coil, that is solenoid, and centered with this is a electromagnetic coil. So this coil is receiving the current from here. That current will flow through this coil. It is like this. Following the arrow head and tail convention shown in the coil winding, the dots versus X marks. So it is going down and coming up. Going down and coming up. This current is flowing through the coil like this. And going into the page for the coil wrapped around the beam. The right hand rule tells us that the beam will magnetize with the right hand side being north. So this beam will be magnetized because of this electromagnetic coil, and this right side will become a north pole and left side become a south pole. And this will torque the beam. So it develops a certain force, rotating force, that is a torque the beam. So clockwise. So the torque will rotate the beam, pushes the beam down clockwise because of this magnetic force. This will torque the beam clockwise around its pivot point, that is a fulcrum. This is a pivot point. So this beam is not freely handling, it is a pivoted at the center. It is also called fulcrum. pushing the right hand side down towards the nozzle, pushing this beam. So it is acting as a flapper. Flapper nozzle mechanism is there. This beam acts as a flapper and pushes the, because of this magnetic field, it pushes down. So because of this north and the south, so this beam will comes down closer to the nozzle, thereby developing the back pressure in the nozzle. Any advance of beam towards the nozzle will increase the nozzle back pressure, which is then fed to the balancing bellows, at the other end of the beam. So at the other end of the beam, this pressure goes and balances the beam. At the end of the that bellows provides a restoring force to the beam to return it to nearly to its original position. So it's almost it balances and comes closer to the nozzle, thereby developing a back pressure. So that back pressure goes to the pneumatic relay. This is a pneumatic relay formed because of this spring-loaded needle valve and diaphragms. This back pressure develops because of this compressed air supply, and output is generated precisely pneumatic signal output, that is 3 to 15 psi. So as the pressure develops, back pressure develops and back pressure goes down, so this will be precisely converted into a standard 3 to 15 pneumatic signal that goes to the positioner, thereby operating the pneumatic actuator. So this is the working of the electro-pneumatic converter.